Here we go. We are in. I'm not going to spook you, don't worry. Unit 2. Finally, we are still doing equations. And we are doing day 2. Fractions and different exponents. Making stuff up as we go. So we're still going to be combining like terms, but we're going to be combining like terms in fraction form and if something has a different exponent. Okay, so we'll keep you awake, okay? That's my goal today. Okay. So we're going to be talking about fractions and different exponents. So, here we go. First things first. If I've got just wait, Swill. Okay. Are you awake? You look awake now. Okay. Here we go. So, if I've got 1/4 of an x plus 2/4 x, do we have like terms? Okay, Sammy, you're saying yes. Why?
Because they're both fractions and they both have the same variable.
Okay, so that's the key. They both just have x's. I don't care about the number in front. They both have x's. 1/4 of an x plus 2/4 of an x. When we have like terms, we know that we're going to be adding the coefficients. In this case, my fraction both have a denominator of 4. To add or subtract fractions, you need to have the same denominator. So, when we're adding the x's, we know we're going to have x's. The denominators are going to stay as a 4. Then we add the numerator. 1 plus 2 is 3. Gives me 3/4 of an x. Is that hard?
No.
As long as the denominator is the same, pretty easy. Isabella?
Would you write it in decimal form too?
No, if it starts as a fraction, keep it as a fraction. In math, for us especially, I'm going to want things in fractions and not decimals. Okay? Everybody still with me? So if I give you this problem, let's go 1/2 x plus 7 minus 5. Actually, let's go 6/2 x plus 2. We still have like terms. In this case, do we have just x's? Well, yeah. We've got 1/2 x. And what else do we have? Raise your hands. What else do we have? I've heard from Sammy too many times. Bianca. Negative 6/2 x. We know that when we combine like terms, we're going to keep the variable. So we've got our x. Is my denominator the same? Yeah. So we're going to keep the denominator. The only thing we're concerned about now is the numerator. 1 minus 6. Brendan.
Why'd you say 6/2?
Because that's what it is. 6/2 is 6/2. Those are halves. This is 1/2. This is 6/2. So, what is 1 minus 6? Gracie? Negative 5. So now I have negative 5 halves x. Am I done there? No. Swill, what do I do? What do I do next?
I'm gonna add 7 and 2.
So, gonna box those in, 7 plus 2 then gives me a positive 9. I cannot combine my x values with the 9. Okay? Questions? Pretty easy, right? As long as the denominator is the same, no problems. So when I was in Virginia, teaching the gifted students and the honors students, they had trouble with this. I want to see if you can be better than them. So, if I give you x over 7, how many x's do I have there? So raise your hands, because I see a lot of fingers. I see a lot of fingers of, hey, this is how many. And a lot of you are saying something that I would expect. Brooklyn? 1. So what do you mean where I say 1? How many x's are there? So you're saying that you're going to have to put a 1 right there, right? Here's my next question. This is 1x over 7. Is this the same?
No. Yes.
Yes, it is. This is 1/7 of an x, which can be written like this. Okay? Just like if I showed you 3x divided by 7, what could I do to write that differently? Grego?
3 over 7 to the x.
Not to the x, but 3/7 times x. Okay, to the x means it's a power. Okay, so 3/7 times x. Everybody with me? Does that make sense? So 3/7 of x. So I only have a portion of my x. Yes? So if I said simplify, and I gave you x over 5 plus 4 plus 3/5 x, I would suggest rewriting the problem. How would I rewrite this problem to start? What do you think I should do, Brandon?
Put a 1 in front of the x.
Okay, well that's adding that 1, but how am I going to rewrite this? Isabella?
Put the fractions next to each other that have the same denominators.
Not quite yet. Brooklyn?
1 over 5x plus 4 plus 3/5 x.
Yeah. I want to write the whole problem back out. The reason we do this is because now I can say, oh, here's my x's, here's my x's. Everybody still with me there? What are my like terms, Simone?
1/5 and
1/5 x and?
3/5. 3/5.
Caleb, what do we have to, not just 3/5, what do we have to add with it?
Positive.
Oh, the plus 3/5 x. You always have to include the sign with the number. So, now we can say, okay, we've got 1/5 plus 3/5, which is still going to be my x value. 1/5 plus 3/5. Well, the denominator is the same, so the denominator stays. Then we're only worried about the numerator. Evan, right? 1 plus 3, Evan.
1 plus 3 is 4.
Thank you for repeating the question.
Yeah.
4/5 x. Okay? That really means 4/5 times x. Well, what's left over?
Plus 4.
So what happens to that plus 4?
Put it in the
You just bring it on down. Bring it on down, bring it on down.
multiply and subtract.
And there it is. That's simplified. Bianca, you stretching, you have a question?
I'm straight.
Okay. Questions on that? Now, only one more thing and then I'm going to give you some practice because I want to give you plenty of time to finish up homework because I really want to make it classwork. here's the question. Is x squared a like term with x? So are x squared and x like terms? If I'm asking you the question, let's use common sense. What do we think? Megan, yes or no? Were you asking me a question? No. No. These are not like terms. They have the same variable, but different exponents. Remember, I told you to name them. Okay? So keep your x's. I'm just going to change it to something else. My favorite. I've got my yaks. Right? If I said, do they have the same name? Well, you would tell me no. This is yaks squareds. This is yaks. Are yaks squareds and yaks the same? No, they're not the same name. Does everybody understand that? Yaks squareds aren't the same name as yaks. So are they like terms? No, that's the easiest way to think about it. So if I give you a problem that says 3x squared plus 5 plus 7x plus 2x squared. So copy it down. I'd like you to try to simplify it on your own first. I know that I haven't shown you an example, but I'm guessing that most of you can do this. So try to copy that down and then simplify on your own. Can we see that? Heck yeah, we can. Woo-woo. You all right?
Yeah.
Okay. Sound like my son. My son has croup, double ear infection, all kinds of stuff. He's coughing. He's like, that's not alone. My baby will.
That's not good.
No,
My sister has it.
it's not good either. Okay, favorite mistake. Favorite mistake, because listen, everything that we've talked about exponents, if I showed you x squared times x squared, we said that's keep the base, add the exponents. Does everybody agree with that?
Yeah.
That's multiplying like bases. Are we multiplying anything here? No. So, what are my like bases? Mason, what's something else that I can combine with 3x squared?
2x squared.
What kind of 2x squared, Mason?
Positive 2.
Positive. We have to include the sign. When we combine like terms, you have to keep the name. What is the name? The name are my x squareds. You do nothing with that variable. You don't try to add them. The variable stays. So x squared is going to stay. 3 plus 2 is 5. And then I saw everybody else say, okay, well, there's nothing that I can combine a 5 with, so it comes down. There's nothing that I can combine 7x with, so it comes down.
Well, it'd be wrong if we put positive 7x.
No, ma'am. So the way that I would write this, me personally, this is fine. I try to keep it in descending order. What do I mean by that? Well, I've got 5x squared, then plus 7x, because what's the exponent of an x? Say, Brooklyn. 1 plus 5. This is how I would write my answer, but both of them are fine. Questions there? This is not homework. I want to go over this before you leave. You are combining like terms.